this video, we're going to talk about combining like terms. So before we actually start combining like terms, we have to understand what like terms are. So like terms are terms in an algebraic expression that have the same variables, and those variables are raised to the same exponents. The order of the variables doesn't matter. And the reason for that is the commutative property of multiplication. When we have terms in an expression, I'm going to give you an example, something like xy, the x and the y are being multiplied by each other. That's the operation that's implied when two variables are right next to each other. And we know that with multiplication, the order doesn't matter. xy is the same thing as yx. And if you think about this with a numerical example, you can see that that is true. So for example, 3 times 5 is the same thing as 5 times 3. They're both 15. The order doesn't matter when we multiply things. Okay, so let's go through some examples and identify whether or not they're like terms. So in our first example, we have negative 3x and 2x squared. So first we check, do they have the same variable? Yeah, they both have an x, so that's good. Are those variables raised to the same exponent? Well, this one doesn't show an exponent, which means that its exponent is actually 1. And this one has a 2 because it's x squared. So they don't have the same exponent, so these are they are not like terms. All right, for number 2, we have 4xy and 3yx. So do we have the same variables? We have an x in both of them. We have a y in both of them, okay? And are those variables raised to the same exponents? Yeah, they are, right? X, y, y. So yes, these are like terms. And it doesn't matter, again, that one is xy and the other is yx, because the order of the variables doesn't matter. Okay, let's look at number 3. In number 3, we have negative 8 and 15. So these actually don't have any variables. These are both constants. Constants are terms that only have numbers and no variables. These are constants. And constants are always like terms because having no variables, that's the same. So yes, these are like terms, and all constants are like terms with one another. Okay, if we look at example 4 here, we've got 3ab squared, 5ba squared. Okay, so do we have the same variables? We've got an a, we've got an a, we've got a b, we've got a b. Are they raised to the same exponents? Well, we notice one has a square and the other doesn't in both of them, but if we look, this one is a, this one is a squared. This one is b squared. That one's just b. So the same variables need to have the same exponents. So the a's, this one has a 1, that one has a 2. That doesn't work. Same here. B squared, but this is b to the first power. So because the same variables don't have the same exponents, these are not like terms. Okay, in our last example, we have 6xyz and negative 2yx. Okay, so let's check. We've got an x, we've got an x, we've got a y, we've got a y, we've got a z, and no z. So because that z is missing, these are not like terms. They need to have exactly the same variables. All right, so now that we can identify whether terms are like or not, we need to talk about combining them. So let's look at some longer examples here. Okay, so we're going to go through and identify all the like terms first. I like using different colors to do this or different shapes to circle them. It helps you organize them sometimes. Okay, so let's see. Start with negative 5x. Okay, so let's find all of our like terms. Negative 8 is a constant, so it's not a like term. 3xy squared, well, it's got a y squared. That one didn't, so that's not a like term. Plus 4x, hey, there we go. It has just an x, so that would be a like term. Negative 2xy squared, again, there's a y squared, we don't want that. Plus 7, that's a constant, so it's not a like term. And then plus 6x, and again, it has just an x, so we're good. So those three are like terms. Let's look at the next thing we have in here. We've got negative 8. Negative 8, again, is a constant. So we're going to look for all of the other constants. Those are the terms with no variables. Okay, nope, nope. Here we go, plus 7. And notice that when I'm boxing or underlining these, I'm keeping that symbol to the left of the number, because we always remember to listen to Beyonce and look to the left, and keep that symbol with the term. Okay, next one. Plus 3xy squared. I'm going to circle that one. Okay, so plus 3xy squared. Well, we only have one term left to compare it with. Negative 2xy squared. Okay, so they both have an x. They both have a y squared. So those two are like terms. Next, we are going to combine the like terms. So the way that we combine like terms is we add their coefficients. So let's write all the green terms here. So minus 5x plus 4x plus 6x. These terms are all your x terms, and if we add those all together, we're going to add their coefficients. The coefficient is the number to the left of the variable. So negative 5 plus 4 plus 6. Let's see, 4 and 6 make 10, minus 5 gives us plus 5x. I always like to write the sign plus or minus for these because it helps you remember what's going to happen when you put them together. All right, the next thing that we're going to look at is, let's go with our purple. So we had our constants, negative 8 plus 7. Okay, and if we add those together, negative 8 plus 7 gives us negative 1. And then finally, if we look at our orange circled ones here, we have plus 3xy squared minus 2xy squared. And if we add plus 3 minus 2 together, we have 1xy squared, and that's positive. Okay. Now, our final thing that we need to do is put these all together into one statement. Usually, we're going to start with the one that has either the most variables or the highest degree exponent. Highest degree just means the biggest exponent. So this one has both. It has a square and it has two variables. That's the most. When we write this, when we have a coefficient of 1, we actually don't need to write the 1. It's just like when we're talking about objects, and if I say I have 3 apples, I need to say the 3, but if I say an apple, I have one, I have an apple, that means I have 1 apple. And it's the same thing here. We don't need to say 1 necessarily. We could just write this as xy squared. We don't need a plus because it's at the beginning. Of course, if it was a minus, we'd want to keep that. Plus 5x minus 1. And this would be our final fully simplified result. Okay, let's look at the next one. We're going to do the same thing here. Let's start with the first term here. So 3xy. So if we look through, let's see which ones are like terms to 3xy. Okay, plus 4 is a constant, so that's not. Negative 7xyz, well, it has an x, it has a y, but it also has a z. So these aren't like terms because they don't have exactly the same variables. Same here, this has 8y, it has a y, but it's missing an x. Plus 5 is a constant. Negative 6xy, oh, there we go. There's one. And again, this last term has a z, so we wouldn't do that one. All right. Moving on to the next term, we've got a constant, so let's find all of our other constants. Looks like we just have the 1, plus 5. And then we have these xyz's. So negative 7 xyz's over here, and that one's just a y, and this has negative 11 xyz. And then looks like we need another color for this 8y in the middle. I'm gonna put a little cloud around it. Okay, so just like we did before, we need to group those things. If it helps you to put them in groups like this, like we did in the last problem, you can do that. I'm going to show you the shortcut that you might start taking once you become more comfortable with this. So I'm just going to write in a row using the commutative property that says the order of addition doesn't matter. I can move these terms together. So we have 3xy minus 6xy. I have plus 4 plus 5. I have minus 7xyz minus 11xyz. And then I have plus 8y. And you want to be careful when you do this that you make sure that you get every term here and you don't miss any. So if we look that we had 1, 2, 3, 4, 5, 6, 7 terms originally. Now we have 1, 2, 3, 4, 5, 6, 7. So we got them all. And then the ones that are the same color are like terms. So those are the ones where we can add the coefficients. So 3xy minus 6xy gives us negative 3xy. Plus 4 plus 5 gives us plus 9. Minus 7xyz minus 11xyz gives us a minus 18xyz. And then 8y, well, that was nice. That was all by itself, so we can just keep it as plus 8y. And this would be a perfectly good final answer. If you want to be meticulous, you can also rearrange so the most number of variables is first. Again, this is kind of optional for your final answer, but nice. This is generally the way you'll see answers presented in textbooks and answer keys and that kind of thing, multiple choice questions. So I'm going to start with the most variables first, minus 18xyz minus 3xy plus 8y plus 9. And notice things move with that symbol to the left. Okay, so hopefully you're now getting a better understanding of how to identify and combine like terms in an algebraic expression.